Hey there, I'm Alan Firstenberg.
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two voice devs. Hey Mark, how's it going?
It's going pretty good this week. How about you?
It's been a tiring week, but pretty good. Uh,
Yeah, I'm a little on the tired side too. It's
yeah,
just been lots of things happening this week, but it's always good to reconnect, kind of chat about what's going on and what new things we've learned this week.
yeah. So you were telling me about something that you had just started working with, and I'll be honest, I'm not sure I get it yet. But why don't we talk about it tonight?
Okay, so we're going to talk about the ONNX format, ONNX, and also the ONNX runtime. Now, there's a lot that you can get into a deep level and talk about, what's happening under the covers and all that stuff, but we're not going to do that. We're just going to kind of do an introduction, explain why it exists and why a developer might care about it.
Okay, can we start with what is this?
Yes, we can start with that. So ONNX stands for Open Neural Network Exchange. And if you think about maybe the very first easiest thing to think about is ONNX is a file format. It's a format that you can put a model into. So we're talking about various different types of models. What we're going to talk about today is going to give the example of a BERT model. But when you create a model, an ML engineer might use something like PyTorch or scikit-learn or TensorFlow with Keras. So there's various different tools that a ML engineer, data scientist can use to train a model, right? And then you've got an option of how you save that model. So one choice is, hey, I'm doing something in PyTorch. I can save it in the native format that PyTorch uses to save the model out. And then later, as a developer, I might want to load that model from the file and run some sort of an inference on it. So inference is just kind of the way that you say, I want to put inputs into the model and get an output out.
Okay, so you just answered one of my questions before I asked. Good. I guess the other one, which you kind of alluded to, I just want to make sure I follow, is that when we're talking about putting a model into it, we mean we're going to train a model or fine tune a model or take a model
Yes.
from Hugging Face and just put it in raw. But it's a model that has been prepared to do what we want it to do and is ready to take inputs and give us outputs.
Right. And like I was saying before, you could just use the native format, like whatever you used. If I used PyTorch, I could save the file into a format that then PyTorch could load up and run inference on. If I happened to be a data scientist that was using TensorFlow or Keras, I could save that in a different file format that was more compatible or native to that. And then when I went to do inference, I would load that model up and go ahead and run it. Now, ONNX is an format that you can save a model into, or you can convert a file from one of these other more native formats into ONNX. And the purpose of ONNX is for um, optimization for inference. So before we get to that part, just want to show a quick example. We're going to go ahead and go to Hugging Face here.
Okay.
We've talked about this model before. This is Google's BERT based uncased model. And you can go over to this tab where it talks about different files and versions. If you notice, there's a number of different file formats here. Um,
Oh,
and
okay.
yeah, so if you notice, this TF model H5 format is a TensorFlow, and it's saved in H5 format, which is this a specific type of file format. It can be used for other things, but that's one way that you can save a TensorFlow model. So if I was using TensorFlow, this is the model that I would load in, and then I can fine tune that model, and I could choose to save as an H5 file as well. Or if I'm using PyTorch, I can use this file, this file format, and use this. So there's different formats, but you'll notice that there's one of them is an ONNX file, is an ONNX file. So this is BERT based on case saved in an ONNX format. There's not necessarily anything different or with the file sizes in this particular case. They're all about the same.
Okay.
Now, if I was to switch back over here to this model card on this case, here's the inference API example of filling a mask. And if I say the goal of life is this mask, special mask token, it will go ahead and exit this call. It will run this input into the model and get an output out. And the output is saying that it thinks life is the greatest chance of being the next word or the masked word in this. So this is the output. So we've got the input and the output, and the fact that it's running it against this model, we're running an inference against the model.
Okay.
Okay. Now that talks about the kind of the format and getting it into an ONNX file and a little bit about what inference is. But if you think about kind of the world of a data scientist, ML engineer, they are concerned about training the model or fine tuning it, doing multiple cycles, getting it to a point where the model can be useful. But on the other side, we as developers want to use that model somewhere, right? We want to use this in a case like maybe this is a product where we able to type something in, do some sort of this is you know,
Well,
something where we're like maybe we're filtering something and
so
we're wanting to use this model behind the scenes, but as a developer, so we want to use the model and then we'll get the output out and format it and do whatever we want with it behind the scenes, right?
right. So as a developer, we may want to use a small model for classification, for example,
Mm-hmm.
and so we would train it for classification to do that sort of thing. Um, that's a normal use, and we talked about that a little bit when we were talking about MLOps the other several
Yeah,
episodes ago. So it's those sorts of things is when we would want to be using this. Correct?
correct.
Okay.
So one other point that I want to make about ONNX file format in itself is it is optimized for inference, which means that things that aren't needed for inference, maybe additional information that would be in the model that would be like architecture, structure of the model that would help you fine tune it again or anything, then that's taken out of it. So basically, you can take a model from H5 format or PyTorch format and convert it into an ONNX file, but you can't convert it back. Think of it roughly like you have an image that you take from your camera and it's in raw format, and then you save it as a JPEG, for example. JPEG is a lossy format, so
Okay.
some of the information is going to get lost, but there's a reason for it. You can get a lot smaller file sizes. It works great on the web, and so there's reasons why you might want to do that, but you can't really convert it back and get those things back that it lost.
Okay.
So that's roughly what's happening is there's optimizations that are happening as things are getting into the ONNX format that will greatly benefit when it's used in inference, but now you've lost the ability to take that ONNX file and train it further.
Hmm. Okay.
So we've talked about the ML engineer where there could be multiple teams, or they could choose whatever thing that they wanted to, whatever language library that they wanted to train a model. Now, if I were to, for example, um, be a machine learning engineer that created a model and saved it in a format for PyTorch, then I could load that back up and run inference on it. But I would have to find a library that could do that. So maybe maybe that's in Python,
Hmm.
but maybe the developer who wants to consume and use my model isn't using Python at all. And so they would have to try to find some library that would be able to load PyTorch in whatever language it is, whether it be JavaScript or C Sharp or whatever else, right? So
Okay.
you kind of got a problem there where you want your data scientists to be free to use whatever they want to train and get a model into a specific format, but you also want the software developers that are creating APIs or applications or whatever based on a model to be able to use whatever language or platform that they want to, right?
And this is an issue. I mean, I could be wrong. I probably will be wrong, but PyTorch, the output format for that, runs on PyTorch in Python and nothing else. And TensorFlow, TensorFlow's format works in Python because that's where TensorFlow runs. And there is a version of the TensorFlow runtime for JavaScript. So these are pretty narrow.
Yeah. So what ONNX does is if you can get the model into an ONNX format, then you can use an ONNX runtime for whatever platform and language that you want to load that model and then run inference on it.
Okay, and they have developed this runtime for various different platforms. It sounds like.
Yes. So
So
that's where we're going to go ahead.
so so this. I mean, I'm a little amused by this because this is kind of the technique that ages ago Java took, and actually before that, um, there were a lot of Pascal compilers that did the same thing. That they had this virtual machine that was defined and could be written in anything for any platform. The catch was so you would need to modify the runtime system, the VM, but the binary, the Java binary, would work on all of them because it was defined in a uniform way. And now you're saying they've done that for machine learning models as well.
Yeah, I'm not exactly sure like how it's implemented. So I don't know if there is some sort of core that's written in, C or C++ that other stuff to build on top of it, or if it's, written per platform per language. But yeah, what's the goal is to give developers a lot of freedom in how they use these models, where they're going to deploy them, and what applications. And if you think about it, this started off. I think the ONNX format started off with Facebook, and then Amazon and Microsoft joined in, and Microsoft's become a really big partner with it. And if you think about different places like on Bing or other places where Microsoft uses machine learning under the covers, then you'd want and you've already got existing applications that have been around for a long time. You're not going to rewrite them in Python, for example, because
Mm-hmm.
you've got a PyTorch model that you want to use. So that's the conundrum that they're trying to solve: is how can we use this model over and over again in an efficient manner? And it being optimized for inference means once I've got this model in this format, I want to use it. I want to put inputs, get outputs in and out of it as fast as possible. I don't care about training it again. I just want to use it as efficiently as possible. And so
This makes
that's
sense.
kind of
So
the idea.
so again, you have something that will take the source code that is PyTorch, and you are compiling it into ONNX format so that you
Yeah.
can run it on an ONNX virtual machine. This makes sense to me. Okay. So far, this makes sense to me anyway.
So let's go ahead and go to the ONNX Runtime website, and I kind of give you a little bit of intro of like who kind of started this. But you notice all these are trusted by all these different companies are using um, this ONNX format. So there is this consortium of sorts that are getting behind ONNX as a format and ONNX runtime as ways to run models that have been saved to ONNX format.
Okay.
So that's kind of what this part does. Um, Separate information here. We'll go into the code section here in just a minute, but I wanted just to kind of walk through some of these things that's talking about, being cross-platform, Python, C Sharp, C++, JavaScript. So various things about that. Um, whether it's running on a GPU or just a CPU. So that's another thing that you might want to have to consider as a developer that's consuming a model for inference would be what types of acceleration or whatever you can use on that. Here's a section that's talking about the inferencing side. There is a slide that talks about ONNX runtime training, which I've not really, haven't even looked at all. But if we were to click in and at this ONNX runtime inferencing, then we can take a look. And here it's talking about varying source frameworks like PyTorch, Hugging Face, TensorFlow, as well as different hardware stacks. And it's talking about Python, C++, C#. So this is kind of giving a little bit more of some information on some of the different libraries and runtimes that the ONNX runtime works in. But you also can come down here to ONNX Mobile, and you can see that it works on Android and iOS with Java and Kotlin and Objective-C. You can also see that there is an ONNX runtime for web, so you can run a model inside of a browser.
Oh,
And we're talking,
interesting.
and we're talking about working on Windows, on Mac, on Linux, on iOS, on Android. So lots of different. It may not have complete coverage for for everything, or but there's a lot greater chance that it will match what you're using or something close to what you want it to be for the project you're working on.
Interesting.
So it separate the concerns. Data scientists are free to use whatever they want. Developers can use a runtime that matches what they need, and the same model could be used in lots of different places.
Okay. What is the procedure to take, to go from a PyTorch model file to an ONNX model file?
So there are converter libraries that you would use. Typically, you go through the training process, and the last step to save a file, for example, to an H5, a TensorFlow model to an H5 format is some sort of a save function. Well, you can then run a converter on that. You don't even necessarily have to save it. You could save it as an H5 and then load it as an H5 and save it as an ONNX, or you can just take the model right before save, run a convert on it, and then save it, use the converter save to save it in ONNX format. So it's just a few lines of code to actually get that converted from one format into the ONNX format. So
Okay, and
pretty
this would be
pretty
something
pretty
you.
light on that side of things.
Okay, and this would be something that you would do as like the last step of the training
Yeah.
uh, program that you're running. Okay.
At the point where you're saving the model to disk, then that's the step that you would save it as an ONNX file instead.
Okay. Now, I guess going back to my poor mental mapping with JVMs, one of the issues with JVMs and with VMs in general is that they're slower than their more native counterparts. I can't imagine that would be terribly popular in the machine learning world if running it in
Yeah,
ONNX was significantly slower than
yeah,
otherwise.
and it's not. It's slower. So that's where the analogy of a VM might break down, um, because it is definitely built for optimization and performance for inference. So some of the examples, things that I was watching, for example, took a BERT model that was saved in, let's say, TensorFlow, and an inference was run on that. And then if you were to take that same thing, save it as an ONNX file, and then use the ONNX runtime to run the inference on it, it was like 2.8 times faster.
Hmm.
So it's significantly faster.
Okay.
Loading the model time is loading a model is faster. So we're talking about, once again, on the runtime side. So the application or service that's consuming the model, to load that into memory faster, with ONNX, actually running an inference through it faster. So whatever they're doing, under the hood, so to speak, on that, to make that optimization is something that is all about performance and speed and throughput. So
All
Now,
right.
you might ask as a developer, well, how hard is it going to be to consume one of these models to use for inference? So let's start off with JavaScript, for example. So here we're importing in the ONNX runtime. We have a path to our ONNX model file. We're going to create a inference session. So this is basically the point where the model is loaded from disk into memory. So now you have a session. And depending on what type of model you'll have, there's different input, you know, so you have to figure that part out. So as far as what the input is, but the basic structure of it is input. You pass it in the input, you do a session.run, and you get the output. And but the thing is that you'll already know this because it's pretty much the same as what the inputs are that you would have passed to the model if it was in its more native format, and the outputs are pretty much the same as what you would get. Now I say pretty much because it might be like in if you're doing something like Python, you might have NumPy array format as opposed to some other format, and so there might be slight differences depending on what library and what you're using, but it's pretty straightforward. It's basically loading the model and calling to create a session and then running it with inputs and getting an output back.
Okay. So let's see what the Python code looks like. I imagine
So
much the same.
yeah, pretty much the same here. Let's go back here to Python. So here it's the ONNX runtime. You've got a model path, which points to your ONNX file. You're creating an inference session path, passing that in. So that's when it loads it from disk. And then you do a session.run. And you pass in the input and you get the outputs. Similar with C#, right? Same
Yeah.
type of thing. I haven't looked at this. What
I'm
else did
curious,
they
what other
say?
ones are there?
So, like we could look at mobile. Let's see what they talk about. So the mobile runtime. So this will go through what you would need to do for Android. Um, this might be you might actually have to build this runtime for Android. Let's see. I'm not seeing the example of the
Not
runtime.
sure what it looks like. Yeah. Okay.
Yeah, I'm not sure what
Interesting
I'm
though.
not sure what it's not sure. This is like building it specifically. So we might be able to go into here some different deployment options. But so that's pretty much what I wanted to share with developers today. That there is an option that might open up possibilities for using machine learning models inside the applications that you're working on today. Um, and there could be a separation from the data scientists and they're doing their work as long as you get it into an ONNX format and however you want to consume it has a supported ONNX runtime, then you should be able to run it just fine.
So very interesting. And I could see how, and again, going back to some of the stuff we talked about before, I can see how this dovetails into MLOps because you're going to want one stage in your pipeline building this ONNX file so that when you're deploying it, it just is deploying this file.
Let me see if I can find one other point here, just kind of a sneak peek. So, Ellen, I think this would be fun to take a look at. So, I just went to the Google BERT-based model under the files and just downloaded this model ONNX file.
Okay.
Um, Now, there's a tool called Netron, and you can load an ONNX file into it. So if you take a look, you can see that one of the inputs into this model is input IDs, token type IDs. So there's, you can just kind of look at, and what happens is that somehow under the cover, each of these things is considered an operator. And so it creates a graph of all the different, paths that need to go on. I won't scroll over there and see what's over there yet. But if you were to click on, for example, here you could get some additional information. So it talks about this. This was, I guess, this was from a PyTorch model originally. Talks about what the input IDs are. So these are the different inputs coming in to the model. So you got input IDs, attention masks, and token type IDs. And then the output is this format, but you can take a look at each of these different steps in here. So let's see. So here's the gather operator. It talks about information about that. It talks about, slice. So I'm definitely not a data scientist, so I don't know what all of this stuff means behind the scenes, but that's kind of an idea of what type of information is being stored inside of an ONNX file that can be then used to better understand what the model is doing under the covers there.
And I mean, I'm no expert in this either, but we do get clues like the gather all the way on the left
Yep.
is 30,000 by 768. So I think we can deduce that that's the size of the tensor that's being operated on here.
Yep.
Okay, interesting.
Yeah. So I just thought it would be interesting. It's an open source tool, Netron, and you can use it. I think you might even be able to load other formats if they're in the right format. But it does support ONNX files, so you can take a look under the cover with that.
Okay, so very interesting stuff.
Thank you.
I think it's clear that these sorts of tools are for data scientists and for people who are working with data scientists on these sorts of things. They're essential. They become part of your deployment set of knowledge.
Yep.
And I'm really curious to hear how what other people are doing to do this. Are they deploying just with a PyTorch file? Are they converting it to something else? I'm really curious to hear how people are doing things now and how this will help them.
Yeah, I'm also interested if anybody has more experience with ONNX and could talk about the improvement that they've seen or their choice to move to ONNX and how that's turned out for
So
them.
as always, folks can reach out to us on social networks or leave comments below. And we'd love to hear your feedback, and we'll talk about this sort of stuff another time on Two Voice Devs.
Two voice devs. Thanks, Alan.
Thank you, Mark. Have a good weekend.
You too.